Okay, in this question, we're looking at reactivity of metals, and this student has put a metal into a excess of sulfuric acid, and they've then repeated it with other metals. We're told that the results and the observations are below, and what they want us to do is use these observations to put the four metals in order of reactivity. So hopefully we can just use the descriptions to help us to do this. And the most reactive one in this list is bubbles produced very quickly and there's no metal left at the end. Then we have bubbles produced quickly and no metal remains. And then we have the bubbles produced slowly. The metal remains, we're getting a change in speed. And then the very last one is the bubbles are made slowly and there's some metal left behind at the end. Okay, so the least reactive is P, going all the way up through to S, as you can see here. Okay, we're started the picture off here with a test tube, and this is the metal and there's the gas being collected, and it wants us to show how we could use this equipment to measure a volume of gas. So what I've drawn here is a sidearm, and the sidearm is coming into a container of water, and this is an upside down measuring cylinder, so I can record the volumes here and making sure I've got a bung here so the gas cannot escape out of the test tube. Okay, this next question is quite a tough one. You've really got to think about what you're doing. My approach to these questions is to do the calculation and see if I can get it to work, and if it works, therefore it's the right answer. So let's have a look at it. We're told that 10 grams of iron powder is reacted with an excess of copper sulfate, and it produces this 11.34 grams of copper. So I'm trying to find which reaction A or reaction B, fits this data. Okay, so the first step, as always, is we are working out how many moles of iron there are inside this mass. Okay, so moles of iron is the mass divided by the MR. The mass is 10. The MR, we're told here that iron is 56. So I've got 10 divided by 56, and I get this many moles. Now that will be the same for reaction A and reaction B, because they're both going to start off with 10 grams of iron. So I'm going to explore reaction A first. So in reaction A, the ratio between the iron and the copper is 1 to 1. So if I've got 0.17 moles of iron, I'm also going to have 0.17 moles of copper. So what I'm going to do now is convert this many moles of copper to a mass of copper. So the mass is the MR times moles. So the MR for copper is 63.5. The moles we just worked out is here, and that gives me an answer of 11.34, which is the same as I was expected to produce. So this means that reaction A is the correct one, but I'm just going to prove that to you. And what I'm going to do here is using reaction B. Now reaction B, the ratio is 2 lots of iron is forming 3 moles of copper. So my ratio is 2 to 3. So put my number of moles of iron, which we've worked out from here, times it by 3 over 2, and this gives me 0.269 moles of copper. Then use my mass calculation, so it's the MR times moles, and that gives me 17.05. So that is actually producing too much copper. So it's definitely not B, and therefore it's got A as an answer. Okay, this next question I think is quite a tough one, especially when it's looking at 2 marks. So we're told that aluminium reacts with hydrochloric acid and it forms a solution containing aluminium ions. Complete the equation to show this, and this one's an ionic equation. So if you remember our general equations, a metal plus acid makes a salt and hydrogen gas. Okay, and what I'm going to do here, underneath this, I'm going to write this out. The acid was HCl, hydrochloric acid. The salt is going to be aluminium chloride, which is AlCl3, and hydrogen, remember, is diatomic H2. If you're not sure why it's AlCl3, I'll just show you over here. So aluminium is a 3 plus ion and chlorine is a minus ion. So aluminium wants to form 3 bonds, chlorine wants to make 1 bond. Swap them over, aluminium gets number 1, chlorine gets number 3. So aluminium chloride is AlCl3. Let's just zoom back out to the question. So here's my equation. I need to balance this equation, so I'm going to use a different colour just to balance this equation. I've got to get my hydrogens to work. So I can see I've got 2 on the right hand side and I've got 1 on the left. To make this work, I know I've got to make it up to a number that they both can become. I'm going to try and get them to 6. So if I multiply this by 6, that gives me 6 hydrogens. And if I put a 3 here, that also gives me 6 hydrogens. This is 6 hydrogens, but there's also 6 chlorines. So I've got 3 here already. So if I put a 2 there, that would give me 6 chlorines, 2 aluminiums. So I need to put a 2 here to give myself 2 of those. Okay. Now that is the balanced equation, but this question wants to give the ionic equation. So what I'm going to do is I'm going to put some charges into this. So hydrochloric acid is H plus and Cl minus. Aluminium chloride is Al3 plus and Cl minus. And hydrogen in the molecule doesn't have a charge. Okay, so if I look at what's going on, my chloride ion is not changing. It's Cl minus, so I'm going to get rid of those. Okay, so what am I left with? I'm left with 2 lots of aluminium, 6 lots of H plus, 2 lots of aluminium ions, and 3 lots of H2. So that is the equation for that reaction. Okay, in this question, hydrogen ion concentration is decreased by a factor of 10. How does the pH change? So what we need to remember here is core knowledge fact that if we change hydrogen ion concentration by 10, the pH is going to change by 1. And because this is a decrease in hydrogen ion concentration, then the pH is going to increase by 1. Okay, so it's heading towards the alkali end of the pH scale. And the last one is a calculation. So to get the marks here, what we need to do is we know that 1 gram of hydrogen, because that's the relative atomic mass, is going to contain 6.02 times 10 to 23 atoms, Avogadro's constant. And what they want us to do is calculate the mass of 1 atom. So to do that, 1 atom is going to be 1 gram divided by Avogadro's constant. So it's the mass divided by Avogadro's constant. And plug that into your calculator and it'll give you this answer as the mass of a hydrogen.